Okay, in this video we're going to do something a little bit different. If you want full credit, you need to, in addition to doing the notes, I'm going to do the notes for the circled ones. You see that there's some have asterisks on them. You're responsible for also doing those in addition to the notes. So if you only do the notes, copy those down, the circled ones we're going to talk about, you get 5 out of 10. If you do all of them, including the asterisk ones, you that's what it takes to get 10 out of 10, or possibly more. See how that goes. Okay, so I'm going to do the circled problems and maybe talk a little bit about the ones that aren't circled. But I'll try not to do those. Leave those for you to work on. What color should we use? So let's look at number 2. Number 2, we actually have an isosceles trapezoid. It's not marked as congruent with the legs, but since they're both 21, since these sides are parallel, it's a trapezoid, and we actually have what we would call an isosceles trapezoid. Now, in an isosceles trapezoid, these top angles with what I would call like base 2 are congruent. So 142 and J goes with K, and then the same side interior angles are supplementary, so 38 degrees would have to be angle M, because together these would have to add up to 180 degrees, and same thing on over here at R, that would also have to be 38 degrees. So in an isosceles trapezoid, you've got these angles congruent to each other. In just a regular trapezoid, you would know that they all have to add up to 360 degrees, but you would only know that these same side interior angles would have to be supplementary. Okay, so for number 2, they want the measure of angle M. Angle M is 38 degrees. Over here with number 1, this is also isosceles, which means that these angles are going to be congruent, and the angles going this way are going to add up to 180, and then you can figure out what these two angles are here at the bottom. Number 3, these angles all need to add up to 360. You get 2 angles given to you. The vertex angles are given to you. These 2 non-vertex angles in a kite, which are consecutive pairs of congruent sides, have to be congruent with each other. So basically you've got 70 plus 36 plus 2 x's makes 360, and you can figure out what each one of those angles has to be. For number 4, we have a kite. One of the properties of a kite is that the diagonals are perpendicular and that the minor diagonal is bisected by the major diagonal. And so let's see. So if we look here, they want the distance from R to H. So this is going to be Pythagorean theorem. 12 squared plus 20 squared, take the square root. That's going to be the distance from R to H, because you have a right triangle there. A squared plus B squared equals C squared. Okay, so get number 6. In a trapezoid, some of the notation we use, or the vocabulary we use, is the 2 parallel sides we call bases, base 1 and base 2. And then the average of the bases, you add them together, divide by 2, you got the mid-segment, or the mid-segment times 2 is going to be the sum of the bases. So that's what these problems are about. Let's look at number 6. They're telling us that LK is 19 and TS is 15. So we've got double the mid-segment is the sum of the bases. So double 15 is going to be the sum of LK, which they give us as 19, plus whatever HJ is. So 19 plus HJ is 30. Take 19 away from both sides. HJ must be 11. If you check, 19 and 11 adds up to 30, divided by 2, you get the mid-segment length. So you got to do the same thing for number 7. Let's look at number 8. Change colors up here. If KL is equal to 17 and JH is 9, so this is the pattern where we've got 17 plus 9 divided by 2 is equal to the mid-segment length, which is ST. So 17 and 9 is 26. 26 divided by 2 is 13. So 13 is the answer for number 8. Then, okay, you guys need to do number 7 if you want full credit. Number 9, we want to verify that EFGH is a trapezoid. They're giving us coordinates. So if I was to sketch out sort of like a general trapezoid type shape, not make it too special or anything like that. They're giving us the vertices, so it doesn't have to be in order. Like we got 1, 3, we got 5, 0, we got 8, negative 5, and we got negative 4, 4. Now let's see. I'm not sure, if it fits this diagram. So we're looking for if it's a trapezoid, then one set of sides is going to be parallel, and the other side's not going to be parallel. So that's how we would verify it. So just kind of start, we would figure out what the slope is from E to F. That's 0 take away 3, change in Y, over 5 take away 1, which is the change in X, and we get negative 3 over 4. So the slope of this segment is negative 3 over 4. If we check any of these other segments, because this may not, well, it would, one of these, this opposite side here, if it has the same slope, then we know we have one pair of parallel sides. But we would also have to check to see if these two sides have the same slope also. So we found the slope of EF. We need to also find the slope of GH. And G was 8, negative 5. So the slope of GH, negative 5 take away 4, negative 9, over 8 take away negative 4, which is 12. So we have a negative 9 over 12, which also is a negative 3 over 4. So it at least looks like these two sides are parallel to each other. Now, to be sure that this isn't a rectangle or a parallelogram, we would also need to check for the slope of EH. And we also need to check for the slope of FG. So that's what you need to finish up on. And if these slopes also end up the same, we have a parallelogram and it's not a trapezoid. If these slopes end up different, then we do have a trapezoid, because we would have exactly one pair of parallel sides. Let's look at number 10. Determine if EFGH is an isosceles trapezoid. Okay, so let me draw this out. Now, if it's an isosceles trapezoid, then these distances are going to be the same. So I'm going to look and see if EH is the same length as FG. So we already found that these two sides are parallel, so it's at least partly a trapezoid. And if these sides weren't parallel, which we don't know for sure, but assuming that they're not parallel, that would cause this to be a trapezoid. If it's an isosceles trapezoid, then these two lengths would have to be equal. So I need to find the distance from E to H and the distance from F to G and compare those. So we'll do over here in pink. So E to H, we're looking for the distance from E to H, this distance here, which is kind of like this hypotenuse of this right triangle idea here. So we want the change in x and change in y. So it's the change in y squared plus the change in x squared. Take the square root. We're going to have the distance. So this is a squared plus b squared is c squared. So looking for the change in y, which we call our a squared one. We're going from 3 to 4, which is a plus 1. Looking for our change in x. We went from 3 to 4, which is a plus 1. We're going from 1 to negative 4, which is a drop down of 5. So we have 5 squared, which is 25, plus 1 squared, which is 1, and we get square root of 26. So the length of EH is 26. Actually, square root of 26. Now, if FG is the same length, we know that we have parallel lines for one set of sides, and the other two sides are the same length. So that would make it an isosceles trapezoid. So let's see what we got from F to G. So distance from F to G. If we look at F up here, we're going in the y direction. We're going from 0 to 5, 0 to negative 5, which is a drop of 5. So say going down this way, we're dropping down 5. It's going to be 5 squared for that part. And going in the x direction, we're going from 5 to 8. That's a distance of 3. So for this one, we have we have 5 squared, square root of 5 squared, which is 25. This one up here was square root of 25 plus 1. This one's going to be square root of 25 plus, and then the distance of 3, or difference of 3, gives us a 9 when we square it. So it's going to be square root of 34. So these are not the same as each other, so it's not isosceles. Let's move on. Okay, you're going to need to do number 1. You got an isosceles trapezoid. These inside angles are going to be supplementary. These angles going horizontally are going to be congruent with each other. Okay, let's look at number 2. Number 2, this is also an isosceles trapezoid. Now in an isosceles trapezoid, we know that the corresponding angles are congruent. So that's going to be a 68. We know that going this way, these have to add up to 180. So if I do 180 take away 68, I get 112. So this other angle must also be 112. And we got an isosceles trapezoid. They want the measure of angle Y. Angle Y is 112 degrees. It's 112 degrees. So get number 3 and 4 here. For number 3, they want the measure of angle Q. Here's a trapezoid. The sum of the inside angles has to be 360. Angle Q and angle S are going to be congruent to each other. So 110 plus 48 subtracted from 360 divided by 2. You're going to be able to find angle Q and angle S. Let's look at number 4. If this is, okay, so they want the length of BC. BC is the hypotenuse of this right triangle. We know it's a right triangle because in a kite, which has the consecutive pairs of congruent sides, in a kite, the diagonals are perpendicular to each other, and the longer diagonal, the major diagonal, bisects the minor diagonal. So we can figure out what this distance is here by basically doing the square root of 7 squared plus 4 squared. So 7 squared is 49, 4 squared is 16. That gives us square root of 65. So BC is the square root of 65 units long. Let's look at, okay, number 5 is one that you need to do. They're telling us that this is V and Y are the midpoints of the legs. So since it's the midpoint of the legs, this VY is the mid-segment because it goes between the two midpoints. That means that the length of VY is going to be twice the sum of the length of FE and CD. That's what you need to do for that one. Let's look at number 7. We want to verify that this is a trapezoid. Okay, so RSTU. So let's do RSTU. So I'm just going to draw, for reference, a trapezoid in there. This time, rather than putting the numbers with the coordinates, I'm just going to kind of refer back to them as we're doing the different sides. So if RSTU is a trapezoid, one of these sets of sides is going to be parallel to each other. So I'm going to check for the RU and the ST sides first, in case they turn this on us. So the slope, I need to find the slope of, M for slope, of RU. And then I want to find the slope of ST. Now if I find that they're parallel to each other, that's one set of parallel sides. Most likely it is a trapezoid. But to be sure, I'd have to also check the slopes of the others to make sure that there's not two sets of parallel sides, because a trapezoid only has one set of parallel sides. And it says verify that it's a trapezoid. So they're telling us that it is a trapezoid. So if we find one set of parallel sides, we're good. So let's look at finding the slope of RU. So from R to U, we're looking for the change in Y first. And so in general, we're kind of doing this change in Y, change in X is the slope. So the change in Y from R to U was going from -3 to -9. That's a difference of 6. It's actually dropping down from -3, another -6. So -6 is the change in the Y. For the change in the X part, we're going from a -3 to a -4. We're going one more negative. That gives us a slope of 6. Let's check for the slope of ST. ST, doing the change in Y, we're going from 1 to -2. So 1 dropping down to -2, that's a drop of -3. And then for T, for S to T, for the change in X, we're going from 5 to -10, 5 to 10. So we're actually going from 5 to 10, we're going up 5. So that's a slope of -3/5. So these sides are not parallel to each other. So now we need to check RS, slope of RS, and slope of UT. So I'm assuming these are going to be parallel, since it is, they imply that it is a trapezoid. So the slope of RS, R to S, we're going from, let's go back this way, 1 to -3 is a drop down of 4. And going from 5 to -3 is a drop down of 8. So we get a 2 for the slope of RS. Let's look at the slope of UT. So we're going from -9 down to -2. That's a rise of 7. And as we're going from, for U, for the X's, we're going from -4 to 10. That's a 14, increase of 14. Which also, that gives us a 1/2 slope. Make sure we did the other one right. So change in Y. Let's do the UT one, change in Y. We're going from -9 to -2. So -9 take away -2 is actually a -7. -9 to -2 gives us a -7. And -4 to 10, negative 4 take away 10 is negative 14. So we get a negative 7 over 14, which is the 1/2. Let's look at the other one. Change in y from r to s. We're going from 1 to a negative 3. That's a negative 4. That's a difference of 4. And then 5 take away negative 3 is 8. 4 over 8. Oh, okay, so I messed up here. I did negative 4 over negative 8 as being 2. It's actually 1/2. So they do match up. Sorry about that. So RSTU is a trapezoid because we've showed that it has exactly one pair of parallel sides. Now to see if this is an isosceles trapezoid, again, we're going to check for the distance, the length of the legs. If the length of the legs are the same, like if RU is the same as ST, it's isosceles. So let's look for the distance from R to S. Now the distance from R to S is also using like a right triangle idea. Now we're going to find the length of this hypotenuse of this right triangle. So we're looking for the change in y, change in x. But this is going to be this change in x squared plus the change in y squared. And take the square root of that. So the distance in the y's from R to S. So we want the distance from R to S. And we want the distance from S to T. Distance from R to U, rather. And the distance from R to T. Okay, so from R to U, the distance. So if we're going from a negative 9 to a negative 3, that's a difference of 6. That's going to give us 6 squared. Then we need to do the same thing for the x's. Going R to U. We've got from a negative 3 to a negative 4. That's the distance of 1. So 36 and 1 is square root of 37. So the length of RU is 37 units, square root of 37 units long, a little bit more than 6. Let's find the distance from S to T. From negative 2 to 1 is a distance of 3. It's going to give us 3 squared. And then for the x part of that, we're going from 5 to 10. That's the distance of 5, which is 25 when we square it. So out of this, we get a square root of 34. So it's not isosceles because these two distances are not the same. Okay, number 10 is left for you to do. I drew a diagram up here to kind of go along with it. You want to know the width of the stairs halfway to the top. So if they didn't supply a diagram, you're expected to supply your own diagram, label it. They want the mid-segment length. It's going to be the average of 21 plus 14, or twice the mid-segment is equal to 21 plus 14. Here for number 10. Okay, so for number 10, this carpenter needs to replace some trapezoid-shaped desks. Let's see what we got here. So let's kind of draw a couple of trapezoids. So here's a couple of possible desktop shapes. You got the exactly one set of parallel sides. So he's going to replace these. He's got the lengths that he needs, but one thing that he's missing is how wide. Whoops, going the wrong way. How wide, or what the distance is between the sides. So that's the other measurement that he needs.